Hi everyone, and welcome back to the second video of my electrical circuits series. In this video, we'll be discussing one of the most fundamental concepts in electrical engineering, voltage. So voltage is a type of electromotive force that causes the flow of electrical current. In this picture, we see two diagrams. The one on the left consists of a pump, a valve, and a nozzle. The picture on the right consists of a battery, a switch, and a light bulb. On the left, we see the pump is forcing the water to flow through the pipes. The water will continue to flow to the valve, and if the valve is turned off, the water will stop flowing. If the valve is turned on, the water will continue to flow through the nozzle constriction. On the right, the battery is forcing the electrons to flow through the wires. If the switch is turned off, the electrons will stop flowing. If the switch is turned on, the electrons will continue to flow to power on the light bulb. So here, the pump is acting like a battery because the pump is causing the water to flow where the battery is causing the electrons to flow. The valve acts like a switch because they both control whether or not the water or the current will flow or not. The nozzle constriction acts like a light bulb because they both restrict the flow of current or water. Now let's go on to formally define what voltage is. Voltage, formally, is the energy required to move a unit charge through an element. And it is measured in volts, which is joules per coulombs. Energy, or work, is measured in joules. And charge, represented by Q, is measured in coulombs. Now let's define our voltage. So voltage is defined by its magnitude and direction. I'll draw two diagrams to analyze. I will label the terminals A, E, or both. In the first diagram, the polarity at VA will be positive and the polarity at B will be negative. In the second diagram, the polarity at A will be negative and the polarity at B will be positive. When we're measuring voltage across an element, we take the higher potential, represented by the positive sign, minus the lower potential, represented by the negative sign. So the voltage across this element on the left will be VA minus VB, which we can set equal to VAB. And the voltage across the element on the right will be VP minus VA, which we can set equal to VBA. The positives and the negatives represent the direction of the voltage. VAB and VBA represents the magnitude of the voltage. As we can see, upon further analysis, VP minus VA is the same thing as negative VA minus VB. And we said before that VA minus VB is VAB. So therefore, VB minus VA will be equal to negative VAB. So from these two circuits, we see that when we flip the signs across the terminal, we also flip the sign of the voltage, which is represented by this example here. When the higher potential is at A and the lower potential is at B, we see positive 9 volts. And when the lower potential is at A and the higher potential is at B, we see negative 9 volts. And that is the end of the video. If you have any questions, feel free to leave them in the comments below. And I'll see you guys in the next video. Goodbye.